Okay, there is a third class of model that is used mostly within Work Block 4, looking at the extremes, which are river basin models. And these are models that need very, very high resolution data. And the design of the models is very specific to a particular river basin. And they know that their models do a very good job in a particular river basin. And one of the exercises in Work Block 4 was to see whether or not the data that we've provided, which is at a 0.5 degree spatial resolution across the world, can be used as an alternative for the sort of local meteorological data that you can get from a weather station to run a river basin model and get sensible results.
Okay.
The results depend on where you are, in the sense that the watch forcing data are, being at 0.5 degree, are representative of basically a 50 kilometre square, so 50 kilometres on a side. And in a lot of areas of the world, that average behaviour, that average variability, if you like, represented by the actual numbers that you put into the models, is perfectly good for across the whole of the area. But if you're in Crete, a 50 kilometre square, and most of these squares don't lie slap bang in the middle of Crete anyway, are actually incorporated areas which are up to 1 kilometre different in elevation. So if you've got very extreme difference in the elevation between a flat alluvial plain next to a coast and then mountains that are 1 kilometre high, the weather inevitably is very different on the mountains compared to in the coast. And in those areas, the watch forcing data is not appropriate, because you need to allow for the very local topographic differences, the differences in the elevation of the rivers and everything else. So in a lot of areas, the watch forcing data is perfectly appropriate, but in some places the river basin models will not work well because the forcing data is not appropriate to the local complexity of the topography of the land surface, if you like.
So what do you do in those instances? Do you just say that's life, or is there another step you take?
In those instances, they have to live with what they've got. There are approximations they can make to changing the data that allow them to make adjustments, so that, for example, if the watch forcing data say that there's going to be rainfall as a particular time step in a particular set of circumstances in terms of the atmosphere, and then you say, well, actually we want to know what would happen if you were 1 kilometre higher in the sky, then you know the temperature would be lower. We know how much the temperature would be low just because it's 1 kilometre higher. And you might decide that because the temperature is that much lower, that it wouldn't have been rain that accumulated, it would have been snow. And those sorts of adjustments, which are not the same as actually doing a proper scientific analysis on what the weather would have been at that time step, it's still better than just using the data raw without adjusting it for the topography.